Hello and welcome to Tonight at 8 from the RSGB. Although the radio is the central part we mainly control and interact with, radio amateurs generally agree that the most important part of a radio station is actually the antenna. Most of us have some kind of limitations on the aerials we can put up, and this is often governed by the size of our garden. So this evening's webinar, Antennas for Small Gardens, is particularly welcome. Our presenter tonight is chair of the RSGB's Propagation Studies Committee and has written several RSGB books, including Stealth Antennas. So who better than to help us make the most of our space than Steve Nichols, G0KYA. Welcome, Steve.
Hi, how are you?
I'm good. How are you?
I'm fine, thank you very much.
We're looking forward to this because antennas really does affect all of us, whatever we do in the hobby. So really looking forward. Just take us through briefly what you're going to do tonight.
We're going to talk about some of the things that people might not think about with antennas, such as modelling and using systems like Whisper to check them out. And then we're going to have a look at a number of stealth type antennas that fit in small gardens.
Great. It sounds really good. So while Steve now gets his slides ready, can I just remind you that if you're watching this on Monday the 29th of June, then this is live. So you can interact with Steve during and straight after the talk with questions and comments on both YouTube and the BATC web streamer. Details on how to sign in and comment on BATC are shown on that page. And please include your Christian name as well as your call sign if you're licensed. Also, please note that you can make this video stream fill your screen on most devices, usually by double-clicking on the picture or clicking on the full screen button. Well, I can still see Steve and not his slides, so hopefully he can change that. I'll just also mention to you at home that I'll leave reading out most of your questions and comments until the end, although if there are any which we feel should be read to Steve during the presentation, then I'll do so. But now back to Steve, G0KYA, with Antennas for Small Gardens.
Yes, thanks, David. We've managed to get the the slideshow up, so that's good. Yes, well, this is a talk for people who don't have antennas like this, really. I mean, this is a sort of frustrating thing about being a radio ham, that if you want to work the world, that's the kind of setup that you might think you could need. But you don't really. You can get by with something a lot smaller than that. So we're going to look at the sort of antennas that you can get for tiny gardens and what sort of things you can work with them. And this is, I mean, I've always had a suburban type garden, so no real room for a mast or tower. So I've always worked with magnetic loops, wire antennas, small verticals and things like that. And I think the first thing we have to say is that if you're working with a small antenna, you have to choose two of these three parameters. You can't have all three. So you can have small and efficient, a bit like a magnetic loop, but that's not very broadband. You can have efficient and broadband, but it certainly won't be very small. Or small and broadband, but it won't be very efficient. So this is a quick guide to really what you can expect from an antenna. Just select two of those three items and you'll be okay. And I think another thing we can talk about here is it's a good idea to model your antenna. And there's free modeling software now. Emanagal software is free. It's based on EasyNet and not too hard to use, but it's well worth trying anyway. So Emanagal software is definitely worth looking at. And I think one of the first questions you have to ask yourself is, what do you want to work? Where do you want to work, really? Because if you're putting an antenna in a garden, you want to align it so that you can work the places you want to work. For example, from here in the UK, if you want to work North America, then you've got to aim for the Northwest. Caribbean is west. Southwest goes to South America. And Australia and New Zealand depend on whether you're on the long or short path. And this map here, this Great Circle map, was produced by a Great Circle map generator, and there's the URL there. And these URLs are going to appear on the program at the end. I think they're going to be put up. So, what do you want to work? I mean, as I said, if we look here, these are two radiation patterns looking down on the antenna, and we're looking at a Hustler vertical. And we're looking at a G5RV antenna. And you can see there that if you were trying to work the West Coast or Canada, the way this G5RV was aligned, there's a null right in the position where you're going to be working into North America. So if you wanted to work north or south, you've got very good lobes there. But if you're trying to work northwest, northeast, southwest, you can see you've got this terrible null. And I think that's one of the things you've got to watch out for. You've got to watch these nulls because you don't really want them to be where you don't need them. This is an extreme example of that case. Roger, G3LDI, who lives quite close to me, has a rhombic antenna on 20 meters. And he wanted me to model this rhombic antenna. Not exactly a stealth antenna by any means, it's massive. But you can see that it works very well into central USA. But he found it didn't really work Florida, and it didn't really work the northwest of the states as well. So it's an extreme example, really, of how an antenna can align it, or you can align an antenna to work a particular region, but it may mean that there's other regions that you can't work at all. So this is why I suggest you model the antenna and what you're trying to put up. And another test you can run is a Whisper test, weak signal propagation reporter test. This is very easy to do. You just set the Whisper system running, and then it will report back to you where you've been heard. And this is a good way of checking whether you're getting in the right direction or not. Now, another way of finding out whether one antenna is better than another is if you run Whisper for maybe 10 cycles, then switch to the other antenna and do it again. Now, I find if you average out the received signal strength from these Whisper beacons, you can then see an average of how you're being received in various parts of the world. It's no good really just taking one set of measurements because they can change in seconds. But if you average a set of 10 up, do for sort of 5 or 10 minutes worth of signals with Whisper, and then average them out, you'll get a better idea of how well it's working for you. Now, what about antennas then? Well, we're going to look at 12 different designs, so you don't have to, as I said here. And these are antennas that I've tested or have used, so I've got a fairly good idea how well they work. And the first one is quite an odd antenna here. This is an isotron, a very odd looking antenna, but it has like a coil in the middle and then end plates that basically it's an LC circuit that resonates at the frequency. They're very lightweight, they're not terribly big. I think the 80 meter version here, as you can see, is about 4 foot tall. I tested these for Radcom a few years ago, and okay, does it work brilliantly? Well, no, not really, but it does work. And it just shows you that they actually make one for top band as well, 160 meters. But it's not a bad little antenna. This is the 40 meter one, and I found that the 80 meter one had a 3-to-1 SWR bandwidth of about 56 kilohertz. So it's quite narrow, and the noise level was about 3 S points down lower than my wire antennas. But then again, signals were also down 2 to 3 S points. But that isn't always bad news really on 80 meters, because an average 80 meter signal in the evening is probably about 40 to 50 dB over 9. So it just means you're going to be S9 instead of 40 dB over 9. So it's not bad, and it's better than nothing. I think the best antenna you can always have is the one you actually put up. And if you think, well, I haven't got room for 80 meter antenna, an isotron will get you there when other antennas might fail or might not even fit in the garden. So I'm not saying the isotron is the best thing in the world, but it does show you that you've only got a tiny, tiny postage stamp garden, you can get on 80 meters and 40 meters. Now, the G5RV is obviously very well known. Very popular. I've got mixed feelings about the G5RV. I don't necessarily think they work as well as people say they would, and I'm going to try and prove that to you now. What we've got here is I've got a recording of a contact with J5C Guinea-Bissau, and what we're going to hear it on a dipole, then you'll hear a blip as I switch to a G5RV, and this shows you what I was saying about making sure the station you want to work is actually on one of the antenna's lobes and not into a null. If it's in a null, it's going to disappear, and it's exactly what does happen. So I'm going to play it now, and you'll first of all you'll hear it on a dipole, Then you'll hear a blip, and we'll go to the G5RV, and you'll hear it just disappears. Here we go. This is the dipole. And that's the G5RV. Back to the dipole again, because he just vanished. And back to the G5RV. He's just there if you listen very, very carefully. So the other thing about the G5RV is these are the SWR measurements I took with it. And the figures in brackets are at the bottom of the matching section. And then the figures outside of the brackets are at the end of 30 feet of RG58 coax. And you'll see that the antenna matches reasonably well on 80 meters. It's not too bad on 40. It's absolutely dire on 30 meters, as you can see, in excess of 31:1. And on 10 meters, actually, 28 megs, it's not a terribly good match. But notice how putting 30 feet of coax on and measuring the SWR makes it look an awful lot better. And that's classic, because that's the case of if you add coax to an antenna, the losses in the coax will mask the SWR, make the SWR look a lot better. So in other words, if you put about 100 feet of coax on this thing, it'd probably be about 1 to 1.5, and you think, well, this is marvelous. But just measuring it at the bottom of the the matching section, we're seeing SWR figures there like 9.6 to 1, 14.8 to 1, 12.4 to 1, which is typical. So if you do put an antenna up, don't just put a load of coax on it and expect it to work perfectly, because you're going to get massive losses in the coax, and you really don't know what the SWR is unless you take as much of the coax off as possible, measure it. And that's another good reason for staying away from the G5RV. Yeah, they're cheap, they work, but it's not a brilliant antenna. This is another test. I'll give you the details of the web address for this later. This is a system that you can call up on your web, and you can put in the antenna, or sorry, the coax, the SWR that is going into the coax, and this will present the table of losses. So on this particular system, we were saying we've got a 12.4 to 1 SWR on the antenna, putting 100 watts, but actually we're only getting about 46.891 watts out. We've got 3 dB of loss on the coax. So again, we're losing 3 dB of our power by going into the antenna with rotten coax. So I think the thing about coax is buy the best coax you can. Try to keep the run as short as possible, but try and get a good match before you start adding coax to it. And this is another system every antenna I've ever tested, and I've tested an awful lot now, is I keep very detailed notes, because otherwise you come back to it in 2 years' time and you can't remember how good it was. So I always make notes like this, which shows every band that I've tested it on. Was the noise level better, worse? Was it, and how did it compare to another antenna? All these are compared with a dipole. So you can see there on 40 meters, the noise level 2 S points better on the G5RV, and the signal strengths were no different around Europe. Noise level S4 on G5RV, S5 on long wire, S7 on a magnetic loop. Signal strengths are either +1 or -2 S points compared with a mag loop. So I think this kind of testing, or this kind of notes that you make whenever you put an antenna up, work really, really well. If you keep them in a folder, then when people come back to it in a couple of years' time, or you come back to the antenna in a couple of years' time, you can see how well it's working. Now, another antenna that played with extensively is this so-called W5GI mystery antenna. It's called a mystery antenna because, well, they say people can't actually model how well it works, but it's about the same sort of length as a G5RV, but it has 15'6" of coax, 15'6" of wire, then a coax that's shorted at one end, then wire again. We'll give you the link to this at the end as well. And we find the club, we made quite a few of these, and I'm actually using one at the moment. But on 80 meters, it's not too bad. They're very cheap to make. Does have some nulls, as I said. It's a bit like a G5RV in terms of the pattern. Low SWR many bands, a bit of a compromise on some bands. I said the jury is still out. We need to do some extensive testing, I think, to compare this with a G5RV. But for 80 meters and 40 meters, I found it works very, very well indeed. On 20, it's not so bad either. It's actually designed for 20 meters, but much beyond 20, it's quite poor. Which is another point I really want to make, is that having a single antenna is okay, but if you have a longer antenna, say for 80 meters, cut for 80, you may find the performance on 15 and upwards, 15, 12 and 10 meters is not so good. You're probably better off, if you can, as having multiple antennas, if you've got the space. One for the low bands, say 80, 40, and one for the higher bands. Because I haven't yet found a long antenna that performs terribly well. And I think it's down to the nulls again. I think all antennas have a very complex pattern as you go up in frequency. And if the station you're trying to work is right on that null, you're going to have problems with it. Now, what about commercial antennas? This is the Cushcraft R5 vertical, which I used for a couple of years. And it wasn't bad. It was about as good as a dipole. Didn't like high winds, though. Ended up in the neighbour's garden and had to go and retrieve it. But I've got nothing against commercial antennas at all, but they do tend to be expensive nowadays. So you need to check the right one. And another good way of checking antennas is to see what people say about them on eham.net. Eham has got a great antenna section with people having reviews, and you'll get a fairly good idea of whether something works or not. People will give you their honest opinion. And it is odd. Some people will swear by an antenna, some people will swear at it, but it's a good way of checking out an antenna before you go and put your hard-earned cash down on the counter to buy one. Cushcraft MA5V was another one I used for a while. The results, not bad. It was 2 S points on 20. It was better on 17 and up. So it's minus 2 S points on 20 compared with a dipole. It was better on 17 meters and up. I did find that the SWR went up in the wet, which is annoying. But not a bad little antenna. But again, these are probably 260, 270 pounds. So you pay your money, you take your choice. Now, this is an interesting little antenna that you can build yourself. It's called the Ribicoff 806 vertical. It's either 7.6 or 8.6 meters tall, and it uses a 4-to-1 Unnen at the bottom. And it's called the 806 because it theoretically can work from 80 meters to 6 meters. And Ribicoff is actually Russian for fisherman or family of a fisherman. That's where the term comes from. And it's because you tend to use a fishing rod, a fiberglass fishing rod to hold it up. And the thing is, you can build one of these for about 20, 25 pounds. So you're not wasting a lot of money. We built quite a few of these, and they work. You do need to put radials on them, though. It does need radials on the ground to make it work. How many radials? As many as you can put down. You'll probably find that up to maybe 32 radials, you'll start to see an improvement. But they're quite cheap to make. The only cost really is the fishing pole, and I can get those off eBay, or Sandpiper sell them as well. Sandpiper in Wales, good company. Then you can build the 4-to-1 Unnen yourself from I think I had a T200 toroid. But it's fun building antennas, and these kind of work for you. Not brilliant, but kind of work. And as a multi-band antenna, I don't think you can beat it on the price anyway. Okay, the magnetic loops. People either, I wouldn't say love them or hate them. But they either love them because they've got one and can't use anything else, or hate them because they've never tried one. For their size, they're probably one of the best, most efficient small antennas there is. The downside is that you do have very, very low bandwidth on them. This is the MFJ 1786 magnetic loop. It will run from 10 megahertz to 30 megahertz, and you tune it with the box of tricks there. you tune it to a band, it will move to a band automatically, but then you have to fine tune it with the buttons. They're better outdoors. I have run one of these in a loft, and it does work, but they're relatively low noise. But tuning can be a bit of a pain, and I would imagine that if you were trying to run a contest with one of these, it would drive you nuts if you're constantly QSYing and having to retune it. But I do know a number of people who use these, and in the Stealth Antennas book, I think we talk about some homemade ones as well, and one that automatically tunes as well. You plug it into the back of the radio, and it will track the tuning as you tune the dial, which is much easier. There's a number of tools available as well on the internet, and there's some calculators that let you work out what sort of capacitor size you need for the loop, and also how efficient these things are. And generally, they're better on the higher bands than lower. For example, on this one, it's better on 10 meters. The efficiency on 10 meters gets very close to, I think it's about 90%. But down on 10 megahertz, the efficiency is down quite a bit. So you have to pay your money, take your choice. The MFJ loops are not cheap. There are other makes available. There's an Italian company, the name escapes me, makes them as well. But I think if you've got no space at all, it's certainly better than nothing. As I said, the best antenna you can ever have is the one you actually put up. Rather than saying, well, I haven't got room for an antenna, try these things and they'll work fine. Hustler 5B TV, the Hustler verticals really sort of war, I think, with butternut. I think that the two of them together, you either go for a Hustler or a butternut if you want a vertical, although high gain are in there as well. I've got the 5B TV, which I've used on and off. It's a trapped vertical, so it has traps that isolate the sections as you go up the vertical. And obviously on 80 meters with the 5B TV, it's using the whole antenna. But on 10 meters, it's only using the small section at the bottom. So not bad. Bandwidth wasn't good on 80 meters. Works quite well for DX. It's not very good for inter-G or close European working, basically because the radiation pattern of a vertical is just not what you're looking for. You want nice high-angle radiation on 80 and 40, really. And these things are generally low-angle radiators. And I think that's an important point to make when you're modeling antennas is what are you trying to work? If you're trying to work around the UK on 80 meters, vertical is not really the way to go. You need to go for a horizontal dipole or doublet to get the radiation angle how you want it. Also, again, the Hustler, you need ground radials, lots of them. Again, how many radials? Probably quite a few. If you just mount one of these on a ground post, you probably have a low SWR. And as you add more and more radials to it, you'll note the SWR goes up. And you think, well, that's a bit odd, but it's in fact working properly. The SWR of a quarter wave vertical is probably meant to be about 1.4 to 1. And if you're seeing 1 to 1, it's probably because you're seeing losses. So as you add more and more radials, you'll see the SWR changes and probably goes up. And eventually, as you've added about 32 radials or getting towards 64, the SWR will not change. And it shows it's working properly. So Hustler have got information on this on their website. It's worth having a look. And Rudy Sevens, N6LF, has written a lot about how to use radials on vertical antennas. And you can read his stuff free of charge on the internet. And he also notes these graphs of efficiency. And as I said, put it on a ground spike with no radials. It will give you a low SWR, but won't work terribly well at all. Even 4 radials will work better than nothing. But as you increase the number of radials, the efficiency will improve dramatically, and this thing will start to come alive. This is another chart that I prepared. You probably can't see all the detail in the chart, but basically it's comparing dipoles with the Hustler on stations all around the world. And I colored it in green if it was louder on the dipoles. As you can see, it's mostly dipoles side is green. Every now and again, you do find a station that is stronger on the Hustler. But again, it's one of those things. You'll notice right at the bottom there in pink, you can't read it probably, it's New Zealand. And it was exactly the same strength between the dipole and the Hustler. So they're not a bad antenna. And I'm going to just play you a little snip of W1AW, the ARRL 40 meter station. And you're going to be listening to the 5B TV, and then you'll hear the dipole. And you tell me if you can spot the difference, because I really can't say there's any difference at all. So let's just play that. As you can hear, just swapping between the antennas there, and there's basically no difference between the two, which probably makes sense because the Hustler is a DX antenna. It's a low angle radiator, so on a path from here to the northern states, probably expect it to be pretty good. And as I said, compared with a 20 meter dipole, I couldn't really see much difference. And the Hustlers they're not cheap by any means. They're a couple of £100, but they are good. And you get the 4B TV, which doesn't have 80 meters, 5B TV, which does, and the 6B TV, which just adds 10 megahertz to it. But if you're thinking about buying one, as I said, do factor in that you need to put down quite a few radials as well to make it work. Put a ground stake in. Yes, you'll have a low SWR. The efficiency won't be that good. And this is just summing it up in this chart here. So just to go through this again, ground radials are non-resonant. If you put a ground radial on the floor, it's going to be detuned by the ground. So you don't need to have resonant radials if they're on the ground. But really, the radial has to be at least the same length as the vertical. So aim for about 32 to 64 of them and make them on the Hustler about 26, 30 feet long. If you can't fit many in, use lots of shorter radials. You'll get better results with lots of shorter radials than you will fewer longer ones. And be careful with the Hustler. Don't cut it to achieve resonance. You have to adjust the traps to get it to work, to get it to resonance. If you start cutting it with a hacksaw, you completely mess it up. And the last thing to point out really about all verticals, they can be noisy. So if you've got a particularly noisy location, and I bet you have if you're in a a suburban area, not all verticals can be noisy. So it's a bit of a shame, but that's one of the things we have to put up with. Okay, we go right cheap now, right to the end. When I first moved into this house, this was the first antenna I put up. I just threw an 84-foot wire up over the roof. And this is the W3 EDP configuration, which is 84 foot of wire, and it is used with a counterpoise. And again, it's a little bit noisy, but it will get you on 80 meters, 40 meters, and 20 meters. It's less efficient on the higher bands. The only problem is, as I said, they tend to be noisy. If you've got this situation and you're running it into an ATU right next to your station, be careful how much power you run, because there'll be so much RF in the shack that you'll probably find your mouse disconnects and USB connections start to go awry, which is a bit of a shame. But if you could arrange for this to be fed outside with a remote ATU or an external ATU, an automatic ATU is probably what I'm trying to say, is they can work quite well. And why 84 foot? Well, 84 foot was chosen at the time as a good length. It's neither a high impedance or a low impedance really on all bands. You can see there that the chart, I've put a line in at 84 feet, and as you see it doesn't go through the middle of any of those bars across there, which are lengths to avoid really. Well, the only one it does really go through is 10 meters, so it's not a terribly good match on 10, but it will match reasonably easily on the others. But I mean, 84-foot piece of wire, how much is that going to cost you straight into an ATU? And this was the configuration I had with my house. As you can see here, the wire went out the window, up over the roof, and then down the garden. And you can see I did some modeling with it, and it was down about 3 dB on a dipole there. But it had slightly better low angle radiation than the other antenna. And I found with this configuration, it would work South Africa quite well. And it was only when I modelled it, I realised it had a very, very strong lobe out to the south. It was pointing at South Africa, but it wasn't so good sort of broadside to the long wire. So it's always a good idea to model these things to see what you're getting. And this is looking at the side-on view of the modelling, and you can see this big lobe pointing out there onto the right, and that was the lobe that fired off to the south. You'll also see you got a very good vertical lobe there on 17 meters, which is not terribly useful. If you're trying to work around the UK, I wouldn't recommend 17 meters, but you know, if you had some sporadic E, it would be brilliant for working around the UK, because it had this massive lobe that went up almost vertically. Finally, well, not finally, we're nearly there anyway. One of the other antennas which I recommend is an inverted V with a fishing pole. So there's that ubiquitous cheap fishing pole again. And there's a lot of sense to using monoband antennas. And if you cut this for the half wavelength at the desired frequency, in this case it was 40 meters, you'll find it'll probably work quite well. I'm a big fan of monoband antennas. They generally work better, I think, than multiband antennas. You could parallel feed dipoles for two bands here. You could have a 40-meter dipole and a 20-meter dipole going to the same feed point. And the point is to get the high current point of the antenna up. And that the high current point on this antenna was at the feed point. So obviously the further you can get it up, the better. And the other thing about using fishing poles like this is that if you're just working at a contest or something like that, you can put it up and take it down again within about 10 minutes, and won't be upsetting the neighbours too much. That tree that you can see there, it's got a lot bigger since I moved here, and I sometimes can hide the pole in that tree, and it comes out the top. But it works okay. And this is for people who've got no garden whatsoever, really. This is the multi-band fan dipole arrangement that I've still got in this house. It's basically a 40-meter antenna, a 17-meter dipole, 20-meter dipole, and then a 10-meter dipole. And they're fed up and down the rafters in the loft like this. Other things that you can do, you can zigzag the antenna up and down there. That's the 40-meter one, a zigzag. So even if you think you couldn't fit a 40-meter dipole in, you can. How well does it work? Well, I've worked T32C Christmas Island on 10 meters with this when we had a few more sunspots anyway. And some other points about this is, if you're going to put an antenna in the loft, watch your power. It's great for QRP. It's great for powers up to maybe kind of 20, 25 watts, but certainly don't run 100 or 200 watts. And wouldn't put a linear on it either. You'll cause absolute mayhem if you do that. But it just goes to show that you can actually get some fun with an indoor antenna. And working Christmas Island T32C was a real bonus with this antenna. I then thought about this and thought, well, maybe I can get 80 meters in the antenna as well. So by putting a 40-meter trap at the end of the 40-meter antenna and then zigzagging a wire along either end, I was actually able to get it to work on 80 meters as well. So again, it just shows you that if you a little bit of ingenuity, you can actually get an 80-meter antenna even if you don't have a garden. How well does it work? Not brilliantly, but I would imagine for FT8, it would be fantastic. With PSK31, it'd be really good. CW would be really, really good as well. So if you like digital modes, or you're a CW operator or a QRP operator, you can actually put antennas in the loft, as we showed in the Stealth Antennas book. So again, just to fold up on what we said about this multi-band fan dipole. So it's suitable for shortwave listeners or for QRP use. M6 licenses, you've only got 10 watts to play with, so you can't do too much damage with 10 watts. Occasional use, maybe up to 50 to 100 watts, but no linears. It uses zigzag loading for 40 and 80. I put a feed point balun to reduce the amount of RF being picked up by the coax because it's in the roof. So that you've got a lot of wiring in your house that could cause issues with it. So putting a balun in helps a lot, helps prevent RFI as well. But it's totally stealthy. No one need know you're even operating, and it's totally weatherproof. Don't have to worry about wind, rain, or lightning. Another antenna that played with a lot, we do Caster International Marconi Day every year, not this year obviously with COVID-19, but we've always used a monoband end-fed half-wave. This is a 20-meter wire with a matching section, the little matching box there. And you'll notice something clever about the matching box. It's an LC circuit, but for the capacitance, we use a piece of coax. We're using coax as a capacitor. So we built, I think it was about 52 of these in the club, and we tuned them all, and they work very, very well. They're very, very efficient. The monoband one, very, very good indeed. Doesn't really need any radials as such, I mean, just a ground spike or a short radial, but it works very well, very efficient. And this was the multiband version. This is a multiband end-fed half-wave that works from 80 to 10 meters. This one works on 80, 40, 20, 15, and 10. And will get you on 80 meters and about 35 feet. It's down about 2 to 3 S points on 80 meters, but it can work. It's not bad. And it's basically just goes straight up the fishing pole, and then out as a sloper, and then add a coil at the end there as a loading coil. The loading coil is such that the antenna on 40 meters and upwards, it doesn't see the end piece of wire, but it acts as a loading coil on 80 meters. It acts as a trap on 40 and higher, but on 80 meters it acts as a loading coil. And so you can get on 80 meters in about 35, 40 feet of garden. And this is the matching unit, the matching transformer for it. And there's been a lot of interest in end-fed half waves over the last few years. And PD7 MAA and Steve Ellington has done some super videos on them as well. And I think we now know more about these than ever before. And you can see there we've got a T240-43 toroid or 240-61 toroid, which is wound as it gives you basically an impedance transformation of 1 to 49 or 49 to 1. Because it's got a 7 to 1 turns ratio, and so therefore if you have a 7 to 1 turns ratio, you get the square of that, so you get 49 to 1 impedance transformation. And it has a little capacitor in there as well, which helps with the matching on the higher bands. Very easy to make, and there's a lot of information on the web now about multiband end-fed half waves. As I said, it's worth looking at PD7 MAA's website. That's where this original design, or where I saw the design originally. But Steve Ellington in the States has done some massive work on them. And he's also worked on adding a compensation coil to bring the SWR down on the higher bands. And also done different work on toroids. And at the moment, he's recommending 52 mix toroids. And they're a little bit more expensive. They're probably twice the cost, but if you can get hold of them, fine. I managed to buy 2 off eBay the other day, but if you can build a 49 to 1 matching transformer with a couple of 240, 52 toroids, it will work up to 100 watts. And you can stack them as well, so you could super glue them together to get up to maybe your 400 watts limit. I won't say a kilowatt SSP, but 400 watts limit you can definitely do with maybe 3 toroids stacked together. Finally, we're getting there now. Off-center fed dipole, another good antenna, which is basically take a half-wave dipole, cut it for 80 meters, break it at the 1/3 and 2/3 point, and feed it with a 4 to 1 balun, and it will work on 80, 40, 20, and 10. Works very, very well. I've used one of those here as well. But again, you've got to have 135 feet of wire really to get it to work, unless you start putting loading coils on the end. And the balun has to be man enough for the power you're running. So if you don't have a man enough toroid in there, it will heat up and the SWR will go up and you could damage it. So again, for 100 watts, they recommend a 240-61. Or 2 of them put together for up to 400 watts. And this is a balun design. This is what is known as a G0KYA balance. It's a balanced design. So you basically wire two toroids, and you wire one of them up in series, one end up in series, and the other end is wired in parallel, and that gives you the 4:1 ratio that you need. And I'm using one of these at the moment, been using one for a few years, and it's not had any problems. Another quick trick with the off-center fed dipole that you can do, I said, feed it at the 1/3, 2/3 point. But if you play with Emanagal modeling software, you'll find that if you move the feed point, you can get an extra band in. If you look at the yellow trace here, that's the conventional 1/3 feed point. But if you look at the pink trace here, you'll suddenly see you get a low SWR on 15 as well. And that's because we've moved the feed point to 41% away from the 33%. Sorry, 33 and a third percent. So we've now got it working on 7 megs, 14 megs, 15 meters, 21 megs, and also 28 megs, 10 meters as well. So you're getting an extra band for nothing. So it's worth playing with these things to see what you can do. So what have we learned then? We've obviously not looked at all the antennas that there are available, but I think we've learned that single band antennas work better than multi-band. If you want a multi-band antenna, it's got to be very carefully designed to work well. Worst come to the worst, think about using a doublet with open wire feeder. That's probably the best multi-band antenna you can make, because you've cut your losses dramatically by using open wire feeder. Only trouble with open wire feeder is you've got to keep it away from all metal objects, and it can be a bit difficult to get into your house. But it is very, very low loss feeder. So don't give up on the doubler, whatever you do. And don't underestimate the half-wave dipole as well. It's interesting that most antennas are compared with a half-wave dipole in terms of gain. And you find that you're hard pushed to beat a half-wave dipole unless you start building Yagis or quads or whatever. Get your maximum current point as high as you can if using dipoles. Get that antenna up as high as you possibly can in the clear. And if you're using a ground-dependent vertical like a Hustler or a butternut, use lots and lots of radials. And you can parallel feed dipoles. That is, you can have different dipoles connected to a common feed point, but keep the wires apart. If you bundle the wires together, you may find you get a low SWR, but the performance won't work terribly well. If you keep them out, nicely spread out, you'll find it will work much, much better. And okay, if you haven't got a garden, don't give up. You can use loft-mounted antennas. You'll lose somewhere between 0 and 2 S points using loft-mounted antennas, depending on what you've got in your loft, really. I mean, I think a lot of metal foil is used in building construction now, which is a bit of a no-no. But as a test, why not get an FM radio, tune it to a station, or medium wave station even, downstairs, and then go up in the loft and see if you can still hear it. That will tell you whether it's going to work or not. And it's a good test, actually, to see whether you've got stuff that's going to block your RF in the loft. Anyway, there's more on some of these designs at G0KYA.blogspot.co.uk. And I think now, David, if you want, we can take some questions.
Absolutely, Steve. Thank you. Yes, thanks for that. I mean, what a big range of subjects about aerials that you've covered there. I know there's lots more, but they're a lot of the popular ones. And so I'm sure we've got some questions on that. We've had a few comments and questions, and we've had a few people answering some of the questions as well as we've been going along. I know you'd be too modest to do this, Steve, but I will mention your book again because I bought this, and I don't buy that many books on it. But Stealth Antennas is really an excellent book, about £12, £14, something like that, from the RSGB shop, and well worth it. Covers a lot of what Steve has talked about tonight, as you know. So if you've got any questions, though, for Steve, he's going to be here for just a little bit longer, and this is a great time to ask them, either on BATC or on YouTube. We'll try and keep track of them. If there's a lot of them, we may have to just pick some of them out to give a variety. But Steve, we need to come to you, but at the moment I can see a big picture of me. So Steve, I need to see a bigger picture of you, really. And I can see your slides now. We're nearly there.
Yeah, hang on, I know what I've done. I need to stop sharing. There we are, stop sharing.
There we go, brilliant. Okay, now we can see you. And I'll ask you, let's say the first question, I think. We had a question from David, actually. He said, hi, I'm a Mac user. Any modelling software for Mac OS X? OS. And that was from his call signs, M0XDF. Greg helped a little bit by saying had he looked at Coco NEC, but I know you use Macs as well. Have you any thoughts of anything good for modelling software on the Mac?
Not really. I mean, most of the software for modelling has been PC based, as you mentioned. I think Coco NEC is probably the only way to do it. And the other way of doing it, I suppose, is to use Parallels or Wine emulator, maybe running on the Mac.
To sort of emulate the Windows on the Macintosh.
Yeah, I've never tried Imanagal running on a Mac with an emulator, but possibly could work.
Okay. Yeah. We've got quite a few questions coming in now, thick and fast, which is all nice. But Tammy and my ex-wife sitting just to my left is helping me sort these. Ed, DD5LP, says, good to create a great Circle MP is https://ns6t.net and then azimuth and then /azimuth.html. I think that came from the BATC website. I'm reading these out partly because most of you are just watching on one of those two platforms, so it'll help you as well. He says that fan dipoles are a good solution if you've got the space, and if portable, linked inverted V antennas, simple, cheap to build, efficient, and wide bandwidth on each band. That was Ed's comments. Phil Davies thinks that Owen Duffy modelled the mystery antenna. Do you know anything about that?
Yeah, it's like they said it couldn't be modelled. Well, I had to play with it, and I think it is possible if you know what you're doing. I think Owen Duffy does know what he's doing. He's an Australian-based ham. The mystery antenna, I don't even like calling it that. I call it a W5GI. It was originally meant to be a number of elements on 20 meters which were fed in phase, but it doesn't really work like that. But it does work on 80 meters, so we tend to stick with it, to be honest.
Okay. Nick, don't have a call sign for him, but he suggested that a Hustler 4x1/4 wave radials per band minimum works at good value for money, but 4 times 20 meter radials is hardly a small garden. Stu Quick replied and said, bend the radials or swirl them out from the base, no problem. So any thoughts on that?
Yeah, absolutely. You don't need quarter wave radials on an antenna. If it's elevated, you need resonant radials, which would be quarter wave length long. But as they're on the ground, it's detuned. So generally, hustlers say the radial should be about the same length as the antenna is high. So it'd be about 26 feet. So you don't need to have quarter wave radials. If you haven't got the space, you can get by with shorter radials. And the more, the merrier.
Okay, good. Max M0VNG had a few comments along your talk. He thought better to have shorter radials than fewer longer ones.
Yeah, absolutely.
Great. As regards Cushcraft multiband and verticals, he had one on top of a building for RayNet use, some 100 foot up and well exposed. After 3 to 4 years, though, the nuts became corroded and it wouldn't tune when fed with an ICOM 7000 and LGD auto tuner. So he's now replaced it by 102 doublet.
Okay.
That's okay.
You summed it up there, really. Yeah, I mean, antennas don't like being outside. You know,
that's unfortunate, isn't it?
It's true. I mean, you know, you put anything up and it will rust. So whenever you put an antenna up, make sure you use proper self-amalgamating tape on all the joints, grease any nuts and bolts there, and it will probably last longer.
All right. Steve, to give us a chance of copying some of these questions, because there are a lot all of a sudden, I'm going to just read a couple of questions to you, and hopefully between us we can remember them while Tammy helps me put those on the screen that I can bring them together. Dennis M7DJC, so a newcomer to the hobby, welcome Dennis. Is there a commercial broadband antenna which could be externally wall-mounted near to the transceiver? And if we can remember this one, Stu Quick says, how critical is wire choice for balance? Some recommend very expensive Teflon coated silver, but how much of a compromise is ordinary insulated or enamelled wire? So firstly, Dennis's question about a commercial broadband antenna which could be externally wall mounted.
Yeah, I mean, that's a good question. There are an awful lot about, but they are not exactly cheap. What I would avoid is these antennas that say they'll cover everything from kind of 80 meters to 10 meters with low SWR. But they generally have a 9-to-1 unn on them, and I don't think they're generally terribly efficient. I did test one here, and it was pretty much down on every band. But I'm not going to put my neck on the block and recommend one particular antenna. But I think anything by the big makes is not bad. Oh, I suppose the other one I would recommend highly is the DX Commander, which is basically a series of quarter wave verticals fed against ground, made by Callum McCormick, and they get good reviews and not terribly expensive. Whether you bolt, I don't think you can really bolt it to the house. It's a garden antenna, but the further you can get the antenna away from the house, the better, really.
Okay, so that back to that wire choice then for balance. Is it worth spending the Teflon coated silver, or will enamel copper wire, that sort of thing, work just as well?
Well, that's interesting because according to Steve Ellington, who's done a lot of work on EFHW, end-fed half waves, he recommends just standard enameled copper wire. No, he doesn't say that you need to have the Teflon on them, and it says that actually it moves the wire away from the balance, so you're getting less of a connection, less of a magnetic flux connection to the toroid itself. But that's odd because, I mean, for years they used to say you should use Teflon coated wire. So I think the jury must be out on that one.
All right. A couple of comments now. Simon M0SIH says that MMNA GAL works fine on Linux with Wine. Used it today on Linux Mint, which I guess is a variation of Linux. So there we are. You've got all three main platforms covered there. Yeah. And G0KYA James said that thoughts on fan quarter wave verticals like the DX Commander range. That came in just before you mentioned him. Cheap, efficient, resonant, and can be covert if built for 20 meters and above.
Yes, and yes. I mean, have a look at Callum's videos. It's a simple design, but he's actually perfected it. Really, he's he water cut plates. And I think one of the elements goes up and then comes across the top and then comes back down again and is used. I think that's on 40 meters. But again, it's down to putting a decent number of radials underneath it, getting it outside in the clear, and feeding it with decent low-loss coax as well. But yeah, definitely look at Callum McCormack's videos.
Okay.
Yeah.
That's great advice. David Batty says, can you talk about folding wire around a very small garden, please?
Oh, I wonder how small is small. I mean, yeah, you can get wire around any garden really, but it's a case of how you do it. I mean, it's best not to fold it back on itself completely. You try and get a zigzag pattern that can work quite well. That's non-inductive loading then. I think that can work quite well. Depends how big the garden is and what band you're trying to get on. If you're trying to get on top band and a tiny garden, you're going to really, really struggle, I think.
Mm-hmm. Dave, G0KBV, says that screwdriver tap antennas are small, relatively efficient, with lots of potential for multiband, but not quick to QSY.
Yeah, similar to the magnetic loop antenna in a way. You have to tune it, and the screwdriver turns an inductor or a core into the inductor on the antenna. But it's one of those things. If you're trying to work stealthily, if you haven't got much of a garden, you have to put up with these things. But yeah, screwdriver antennas were really designed for cars. I think that's where the first designs came from. But it can be quite good. And it, in some respects, get on a band and stay on it is good advice, I think. I think sometimes we just move from band to band, see what's on, and that's not necessarily a good idea. I think it's probably get on one band and stay with it.
Good. Okay. By the way, we've got people watching from all over the world. We've just had a message from KC7WDL. I don't know if you know him, from New Mexico. He's watching.
Oh, lovely.
And a couple of comments from Sweden I saw earlier on as well. So lots of people watching.
Excellent.
Steve. Nick Gar7, that's his name on YouTube, I think. How about some of these buddy pole, super antenna, patio antennas? Ever done any testing, Steve?
I've done some testing with the MP1 antenna, and I think a buddy pole one I've had as well. And again, it gets you on the air. You know, you're not going to be the loudest signal on the band, but they do work. I think the MP1, you slid the coil up and down, had a little slider on it, and you picked the band. That worked reasonably well, but not brilliantly, but not bad.
Okay. Just seen a question not directly related to aerials, but Tristan Thomas has asked, good presentation, Steve. We'll be able to get a copy of your presentation for future reference. Of course, this is being recorded now, and it will be available on the RSGB site from more or less where you're watching. If you're watching on the YouTube channel, on their YouTube channel, certainly by tomorrow. So if you have missed part of this presentation or you'd like to watch some of it again, you'll be able to catch it on there, Tristan. Steve, what antennas do you suggest for a rental house with PME earthing? Strictly half-wave dipoles?
Not necessarily. I mean, the PME side of it is tricky. Basically, I would stay away from anything that's ground related or like a quarter wave vertical. So dipoles are a balanced antenna. So it's probably not such a bad idea. So a balanced antenna or a doublet, maybe. But yeah, the problem is the PME earthing, really. It's not really a massive issue, but there are precautions you have to take. So balanced antenna, which is not ground dependent, is probably the better way to go, I think.
Okay. How about a delta loop stuck on your gable end wall if you've got no garden? That was from Nick again. Nick, M1 DDD. Yeah,
well, a delta loop is a balanced antenna. If you stick it on the end of your wall, yes, it's reasonably high up if you've got a 2-story house. Not a bad idea. I would try and kind of set the wire a little bit further out. You know, if you could mount it on sort of 6-inch extensions or something, just to help a little bit. But yeah, it would work.
Okay.
You probably need to feed it with maybe a 4-to-1 Unan. Let's think about this. Balun, not an Unan, Balun. And to make it multi-band, or open wire feeder from the antenna, and that would work then. So yeah, that would be a multi-band antenna.
Okay. Another couple of things here. DD5LP Ed says to get away from the need for radials, HFJ poles with quarter wave stubs work well on a fishing pole, but these are single band antennas.
Yeah, as I said, I think single band antennas are easier to make than multi-band ones. And if you've got radials that are off the ground, then they need to be resonant. So that's the issue there. So yeah, quarter wave radials mounted off the ground would become a monoband antenna. Yeah.
Okay. From Alan M7MDY, my garden is 4 meters by 10 meters, which I would say is fairly small. New to the hobby and have a slim gym for 2 meters and 70 sems, but not sure what to do for 40 meters and up. Not too worried about 80 and 160 meters, he says, as the garden is surrounded on all sides by other houses, and that's on BATC.
Yeah. Again, so the good point is you've got vertical space. So a 10-meter fishing pole would get you a 10-meter wire up, feed that against the ground, you've got a 40-meter antenna, or plug it into an end-fed matching device, you've then got a 20-meter half-wave antenna. So you get 2 bands out of 1 antenna there, just by the way you feed it. So that could work quite well, and probably be quite efficient, actually, on 20 at least.
Okay. Excuse me, a couple of questions as well. I see mentioning the cobweb type antenna. And another one mentioning the octopus, which I must admit is a new one on me. Any thoughts on me? Any thoughts on cobweb antennas? Yeah,
cobweb antenna is a multi-band antenna that uses folded elements. So I think they work 20 to 10, all 5 bands 20 to 10, and they work quite well. And instead of being like 5 different dipoles, they're folded around, and yeah, they work quite well. Yeah.
There we go. This will stretch you internationally, Steve. From VU3BGI, Jyoti, I hope I've got your name right. He's watching from India. Any recommendations for a 50-foot by 25-foot property?
Again, depends on what bands you want to work. You could have an end-fed half-wave that would work 40, 20, 15, and 10. Or you could have the loading cord as we showed and get it to work on 80 as well. But that's probably the way I'd go, as up and out in a plot like that. It depends what bands you want. If you don't want the lower bands, then I'd probably go for verticals on 20 and up. Or you could, if you just wanted to concentrate on 10 meters, you could have a kind of a push-up mast with a tiny dipole or beam on there for 10 meters. But as I said, it always depends what time of year it is and what you want to work. I mean, at the moment, in Europe at least, with the sporadic E season, everyone's on 6 meters. Everyone's going crazy with 6 meters and 10 meters to a lesser extent. But that won't last much longer. By the time we get to maybe September, sporadic E season will have ended, and then we'll have to start looking at the other HF bands. So 20 meters will start to come into its own late September. And then through the winter, maybe 80. So it depends where you are, what you want to work, and what time of year it is, really.
All right, well, I hope that helped. Mike M0RYK says the GWIP 421, 40, 20 and 10 resonant tri-band end-fed is only 15 metres long. It's a slower, works well and works with other bands with a tuner. It needs 10 to 15 metres coax feeder to work properly. I hope does that make sense?
Yeah. I'm not aware of the antenna, but if he says it works, it works. It's always a case of the best antenna you can have is the one you have up, and if you're working stuff with it, then you're happy. That's the main thing.
Yes, absolutely. Views on the microvert antenna for compromised spaces. That was questions from Paul. Do you know about the microvert?
Yeah, the microvert was designed by a German guy and is a monoband antenna, and I've built a couple here, and they worked. I'm trying to remember I can't remember his name offhand, but if you Google, Google microvert, or you look on YouTube for microvert, you'll find his channel, and it's a couple of videos of these microverts working. They're basically, what they do is it's a loaded quarter wave, really. It's a quarter wave with a loading coil, and then it uses the coax as the other half of the antenna. And then you basically put a choke quarter wave down the coax, so you can get going on 40 meters with this little rod antenna, which is about 7 foot long. But then the coax is the rest of the antenna. So yes, they do work. DL7 something or other, I can't remember what it's called so offhand. I did write to him once and said, any chance of getting your instructions translated into English? But they are available in English now. That's right. He wrote a book. I wanted to get the book translated in English, but he wouldn't let me do it. So yeah, but I think the details are out there. And I mentioned the microvert in the Stealth Antennas book. So I built one for 40 meters.
Good. Okay, another plug for this really good book, and it is good. Honestly, that's an independent view. I bought this book.
Thank you.
It's true, though. It's true. It's a really. If you're going to buy one book on antennas, in fact, that's the one I'd buy. Enough plugs. Got a question here from Graham. G6HBC says, Steve, have you talked about fan dipoles being kept separated, but by how much?
Inches, really, sort of 6 inches or more. Years ago, I bought what was effectively a fan dipole, but all the wires were bound together, and it had low SWR, but on 10 meters, it was absolutely deaf. And it was only then by separating them out, worked out that it actually worked better. So you'll see fan dipoles designs where they're held apart by about 6 inches. And that's probably enough to do it. If you can separate them more than that, fine. But just don't bundle them all together, because it won't work very well.
Okay. It's got a few more. You're right to stay with us a little bit longer?
For a couple of minutes, yes.
Okay. Yeah. Kenny C says, what's important firstly regarding the low frequency bands? What do you want to work, UK and EU or DX, the antenna? You decide one or the other, and a few are both. Sorry, I'm not sure if that... I'm sight reading this, so that's from
I think
Kenny.
I know what he's trying to... I know what he's saying. It's basically 80 metres around the UK is you must have near vertical incidence radiation. You need to get your signal up almost vertically to work around the UK. Around Europe, you can afford to get the radiation pattern down a little bit, maybe sort of 55 degrees, but you won't work much DX with that. But if you want to work America on 80 meters, you need low angle radiation, sort of 5 degrees. As a result, a vertical antenna 480 would work brilliantly on trying to work the States or other DX, but would be pretty rotten around the UK. So he's right. What he's saying is, what do you want to work? There is a point, we think, that around grey line times in the mornings, you'll suddenly find that the signals suddenly get a bit stronger. And we think this is because that due to the ionosphere, you do get a point where you get high angle signals coming in due to kind of ionospheric ducting. So you may find that a fairly low horizontal dipole will work on stateside stuff, but only for about 10 minutes at dawn in the winter. But on the whole, low angle radiation, which you normally get from on 80 meters at least from a vertical, that's the only way you're going to do it. But it's got to be a big vertical to work. But that won't work terribly well around UK or into Europe, because you need high NVIS, near vertical instant skywave. So kind of lowish dipole for 80 meters for working around the UK, but a vertical for working DX.
Okay. John M0MLE says, great presentation, Steve. You mentioned the Wyndham, but could you please comment on the Carolina Wyndham?
Yeah, the Wyndham, technically a Wyndham is a single element which has got a single feed on it, named after Lauren Wyndham. We generally tend to use the term Wyndham when we mean off-center fed dipole. Off-center fed dipole is fed with coax to a balun. Now, the Carolina Wyndham is exactly the same, except that you choke the feed line at a point further down the coax. So you have a dipole fed with a balun, and then you have the coax coming down from that. Then you put a choke on there, and it's designed, you put the choke in exactly the right place where you need it. So you get some vertical radiation off the feeder as well. And that's the Carolina Wyndham, and they work very well.
Okay. Excuse me. John Harrison says, I've got 40 feet of garden that is triangular. A vertical with radials won't work. Only about 15 degrees of space for radials. I get a heap of RF in the house. A ground would need to be 35 foot long.
What band is he on?
He doesn't say, I'm afraid. So
yeah.
I don't know. I don't suppose you can guess on that. No, he doesn't mention that. So, John, if you're very quick, John Harrison, if you quickly put an answer in there for what band, we'll try and come back to that question. Evan, ZS6ELI, says, my Cushcraft R7 is 10 metres up. Can I use the vertical antenna to hold an end-fed half-wave up in an L shape? Would it interfere with each other? Obviously not short-circuited between antennas.
That's a good point. It probably gets some interaction, but if you had a long enough piece of nylon filament off from the antenna to keep it away from the antenna, you'd probably get away with it, I would imagine. Yeah.
Okay. And a question from Jonathan Warner. No call sign, I'm afraid. I've got a height restriction that prevents having a 20-meter quarter wave vertical, but might a quarter wave work okay on a slope?
Yes. If you model a quarter wave vertical and you slope it, you'll find that the radiation pattern changes slightly, but it will work. I'm just intrigued as to what his height restriction is that he couldn't put a quarter wave up. But that'd be about, a quarter wave on 20 meters would be about 5 meters long, wouldn't it? I would imagine about sort of 17 feet. Is that right? I've got that. Yes, I think it'd be about 17 feet. Why not slope it? Try it. Why not?
Okay. I've got an answer back for you from John Harrison. He's on 40 and 20, and he's got an upstairs shack. So that was that question about he's got 40 foot of garden that's triangular.
Yeah. If he's getting RF into the house, be interesting to know whether it's coming from the antenna, radiating off the antenna, or it's coming up the coax. So it might be worth trying a choke in the coax before it enters the house. That might help. But if not, it's just it probably just could be RF just from the antenna, which is just a little bit too close. It's one of those things. It's very, very difficult to get rid of RF in a small plot. But I would try a choke in the feed line to start with to see whether that gets rid of it. If not, it'll just be RF coming straight into the house.
So a choke,
And
by a choke you mean a ferrite, something like that, with the
yeah,
cable wrapped
yeah,
around that?
yeah, a choke on the coaxial cable before it enters the house. You can either make one yourself with a toroid and wind loads and loads of cores around it, or you can buy one. But it sounds like it could be RF coming up the outer of the coax, so-called common mode current. Worth trying at least.
Okay. Thank you very much, Steve. I hope that's helped you, John. We've got Phil G0SXY. It says, all my antennas are in the loft, 40, 20, 17, 15, 12, 4, 2 and 70 SEMS. Any hints and tips on tuning the house wiring and copper pipework to stop interaction?
Oh, I mean, you've got such a wide selection there. It'd be very hard to, I think, to do that. Just keep them as far away from the household wiring and the pipework as you can, and reduce your power, I think, probably. But yeah, it's tricky. Yeah, I wonder how close they are to the pipework. Yeah,
I don't know. Okay.
no.
We've got now Glitz and Shiran says, are loop antennas good around the fence of the garden to use on 80 and 40?
If they're big enough, well, are we talking about a magnetic loop or a wire loop? That's the difference. If we talk about a wire loop, which is like a wavelength long, yeah, you could put one of those around, but you'd have maybe, what would you have? 250, 240 feet of wire. So it's one way of doing it. If you're talking about a magnetic loop, I don't know. Maybe that's what he's talking about. Yeah, you could have a magnetic loop for 80 meters. Excuse me, but
Okay.
it would have to be at least 1.7 meters in diameter.
Okay, Steve.
So
You've done lots of talking for a long time. And
I have. Yeah, I'm starting to.
Well, grab a glass of water while I ask you this. We're on the last final questions now, everybody.
Oh, okay.
So we've got Ed now, DD5LP. He's got a few things here. Delta loop on the end of the house would be detuned by what is in the house, metalwork, etc. Feed with
Right,
Q.
yeah.
He suggests feed with Q section, in his honest opinion, with rather than a balun. Multiband also works over the Q section, even though some say it doesn't. And NVIS also works when the critical frequency is high enough, e.g. it rarely reaches 80 meters, more often on 80 and 60. So propagation is as important as the antenna, and I think you'll be just the man to answer that one.
Yeah. I mean, 80 meters is the classic NVIS band, near vertical instant sine wave, because the critical frequency, that's the frequency at which signals go straight up and then come straight down again, is at the moment it's generally about 5 megahertz or thereabouts. So during the day, and the evening, you'll find that will work around the UK. 40 meters is a little bit too high, so you can work into Europe, where the signals are going up at a slight angle like that, easier than you can work around the UK. But as the sunspots start to improve, you'll suddenly start to find maybe that the critical frequency goes higher, and we'll start to find that you can use 40 meters around the UK. But he's right, absolutely right. NVIS tends to be 80 meters, and to a lesser extent 5 megahertz, 60 meters as well. Anything more than that at the moment, and they're going to, you've got a skip distance of maybe 500 miles or thereabouts. Yeah.
Okay, brilliant. And I'm going to leave almost the last question to someone we both know, Matt M0MPTO. He says, in reference to the coax capacitor for the end-fed half-wave, is it dependent on which band you work? And if so, could you fit a BNC to the box and have multiple cut lengths labelled for each band? Thanks.
Yes, you can. Within reason. It's an LC circuit, so you have the inductance on the toroid, and then you could plug in the coax to resonate that. So yes, probably kind of 2-to-1 ratio. So you could probably make one of those that works on 20, 50, and 10, or 20, 15, 17, and 10. But yeah, I've seen it done. You can do it quite easily. I mean, I've actually got a box of tricks up on the shelf here, which has a big rotary variable capacitor, and that would work. What's it got on there? Yeah, that worked 20 to 12 meters. I couldn't get it. There was the capacitance is too high to get it to work on 10 meters. But yeah, that's the kind of ideas you can have. It's a very cheap way of doing it because the coax is incredibly cheap and you just cut it to get to the resonance you need. But that's the box. You now need the radiator as well. That's got to change its length to suit.
Right. I'm going to leave the last question, if I may, to myself. Just a question for you.
Yeah.
Overall, all these antennas you've tested over the years and all the ones you've used for all sorts of events and everything, what's your favourite all-time, all-round antenna? If you went to that desert island and you could only take one antenna, what would you take?
I'd have to say it'd have to be an end-fed half-wave monoband, the type we use at Caister. I first designed it really about 15 years ago, almost by accident. I was playing with it, and it was only after we made it then we kind of started to work out how to use it. And there's been a lot of interest in end-fed half-waves over the years, but very, very efficient and dead easy to make. It's end-fed, so with a vertical fishing pole, it works very, very well indeed. So yeah, but again, as I said, it depends what you want. If you want a multi-band antenna, you have to, a multi-band end-fed half-wave works, but probably not as well as a half-wave dipole on each of those frequencies. But yeah, that would be my favorite, and that's the one. If we go out and do any portable work, that's generally what gets put in the back of the car.
All right, Steve. Well, thank you ever so much for staying on so much extra time as well at the end of your formal presentation. And thanks to everybody as well watching, of course, for their questions as well. We're really grateful to Steve tonight for sharing all of this knowledge and experience. I know he's had all those years. So once again, thanks very much to Steve Nichols, G0KYA, for tonight. And that ends Tonight at 8. As I said, I'd like to thank very much to Steve. And don't forget that you can get that book, the Stealth Antennas, and all of his books indeed, from the RSGB web shop at rsgbshop.org. We hope you've enjoyed tonight's webinar, and if you'd like to see details of future webinars or send any comments or feedback, please visit www.rsgb.org/webinars. But until next time, this is David G7URP signing off and clear. Good night.